One question you might ask yourself about water vapor in the atmosphere is why there is any water vapor there at all. After all, water boils at 100 degrees Celsius, 212 degrees Fahrenheit, and the Earth isn't anywhere near that hot at the surface. So why is all the water vapor in the atmosphere not in the ocean? Well, the answer is something called water vapor equilibrium, which you can picture on a planetary level, or you can picture it in a closed bottle with a little bit of water at the bottom. So we have here a dry atmosphere without any water vapor in it above the ocean surface. You could also picture this to be just a dry air above a bottle of water in a closed environment. The reasoning applies to both. So we'll assume here a temperature of 300 Kelvin or 27 degrees Celsius. That would be conditions in a tropical ocean. It's important to remember that according to kinetic theory, the air molecules are all moving around randomly, and the water molecules in the ocean are also moving, but they're moving more in a back and forth motion, vibrating, maybe moving, sliding over each other. You can sort of picture it that way. In any case, their kinetic energy is not nearly as fast as the air molecules moving here. So what's going to happen eventually in this case is that one of these molecules over here is, due to random fluctuations, is going to be moving a bit too fast to stay in its liquid state, and it's going to actually evaporate and move into the atmosphere. And that's represented here by this molecule moving into the atmosphere, and that represents evaporation. So several molecules are going to do this, and eventually you're going to have more than one molecule in the atmosphere here, and that's depicted by this situation that you see here. Here we have several of these blue spheres representing water molecules zipping around in the atmosphere and mixing in with the dry air molecules, oxygen and nitrogen. And eventually what's going to happen is some of these molecules, water molecules, are going to lose enough kinetic energy that they begin to stick to the water molecules at the surface here. So in other words, they're going to condense or precipitate in the case of rain. In any case, they're going to go into liquid form back into the ocean here. And eventually what you're going to get is a balance between evaporation and condensation. This state is called vapor equilibrium, and it's valid for the whole, you can think of it as valid for the whole planet, sort of an equilibrium between the atmosphere and the ocean, or you can picture it as at a smaller scale for a lake, or even for a cup of coffee if you wish. Any system involving the atmosphere and water of some sort is going to have this. Now picture what happens if you raise the temperature 5 degrees Celsius of the ocean here. Well, in that case, what's going to happen? These molecules in the ocean are going to start moving faster, and more of them are going to evaporate into the atmosphere. As a result, you get a more humid atmosphere. You have more water vapor zipping around in the atmosphere. As a result, since these things all tend to move into equilibrium, you have more condensation and precipitation to balance out this evaporation. So in other words, if you raise the temperature of the oceans on the planet, you get more humidity in the atmosphere. You get more water vapor in the atmosphere. As a result, you also get more precipitation falling out of the atmosphere. The net result is a little bit less water in the oceans, but that's pretty insignificant compared to the amount of water already in the oceans. However, over land, where the amount of water is limited, you're actually going to get drier land. You're going to get more droughts, okay, despite the fact that you actually have more precipitation. And this is the situation right now over California. California is actually not getting less precipitation than usual. It is, but That's not the only factor involved. The other factor is that it's actually warmer there than average. And as a result, there's more evaporation. So when it does rain, the water evaporates back into the atmosphere instead of moving into the ground. And that's why the drought in California is so severe. Now, on a planetary scale, what this means is with global warming and warmer oceans, you get a drier planet on the land. On the other hand, in the atmosphere, you get an atmosphere that's more full of water vapor.